All right, so here we're looking at theorem one, which is showing marginal cost and exact cost. So if C of x, again, is the total cost of producing x items, then the marginal cost function approximates the exact cost of producing the x plus first item. And we saw that in the previous example. And when we calculated it, this was like $299.25. And when we did the derivative, it was $300. And we can see how it's different here. So if our blue is going to be our function, then when we take the derivative, that's going to be the slope at that line x. And what we have here then is to get the right side, we're just, x plus 1 and the x. Here's our x, we get a value here. X plus 1, we get a value there. That's going to be our difference, basically, the c of x plus 1 minus c of x. And so that's how we're going to get that value. Well, when we do the derivative, what happens is we have this tangent line, and that is going to be our difference. So we can see why it's a little bit different. Now, depending on how your shape of your function is going to be, it could be overestimating or underestimating. In this case, we're, overestimating from 299.25 to 300. So it's overestimating a little bit in our example we already looked at, but that's how it's going to work. And so again, that margin of cost, which is our derivative, is about equal to our exact cost, which we found by plugging in actual numbers. Now, this also works for total revenue functions and total profit functions. So it doesn't just work for the cost, it works for the other two as well. Now, theorem one states that the marginal cost at a given production level X approximates the cost of producing the X plus first item or the next item, basically. And so in practice, the marginal cost is used more frequently than the exact cost. And that's just because it's easier to do one simple derivative, plug in the number and we get answer, than plug in two things for cost and then subtract them. Now, one reason for this is the marginal cost is easily visualized when one is examining the graph of the total cost function. Again, you're looking at that derivative, so that slope there. Now, figure 2 shows the graph of a cost function with tangent lines at 200 and at 500. Now, the graph clearly shows that as production increases, our slope of the line is decreasing. Thus, the cost producing the next tank in this case is going to also decrease. And so that's a desirable characteristic of a total cost function. So if we look here, when we take a derivative at that, it's going to be a steeper line than when we go here at 200, and that's going to be less steep here. And once we get up here, it's even going to be less steep. And so as you move up this curve, the slopes are getting smaller, and therefore our marginal costs are decreasing, which is what we want. And so they've calculated what the marginal costs are at these points. After we've taken the derivative and plugged in the different values. So that's kind of how that works, is we want a cost function that kind of looks like that, because as we get higher and higher, our costs are going to go smaller and smaller per next item. All right, so here it says we have the total cost of producing X bicycles is given by our cost function C of X equals 10,000 plus 150X minus 0.2X squared. And we want to find the exact cost of producing the 141st bicycle, and we want to use marginal cost to approximate the cost of producing the 101st bicycle. All right, well, the first one again is going to be a little harder because we have more work to do. We have to plug in more stuff. And so here we're going to take C of, and we have 141 minus C of 140. And so that's going to be what? Well, we're going to have 10,000 plus 150 times 141, and then minus 0.2 times 141 squared, minus, then we have 10,000 plus 150 times 140 this time, and then minus 0.2 times 140 squared. And so that should give us what the exact cost of doing that is. Now, to save time and having to type all that in, what I've done is I've calculated that. That's going to be $27,173.80. This one is going to be $27,080. And if we do that difference, that's going to be $93.80 for the 141st bike. Okay, so that's the exact cost. Now, marginal cost, well, that's going to be take the derivative of that. So if we take the derivative of that, C prime of X is going to be equal to what? Well, take a derivative of the constant, that goes to 0. Then we get 150 minus 0.4x. And so that's going to be our derivative. And so now we just find C prime of 140. And that's going to be 150 minus 0.4, and that's times 140. And again, plugging that into our calculator, I've already done that, and we get $94 even. Okay. So again, not much difference there. Another reason why most of the time it's easier to use this derivative function because, we can plug that in pretty easy and get it into calculator. This one we had to type a lot more into it, and we're not too far off, 20 cents. That's not too bad. So hopefully that helped on that one. So we'll pause there and we'll come back for more.